All right, so this is our opener on tile patterns. So this opener is, it's difficult for me to make a video on it because it's trying to teach you how to recognize a pattern. And really, that's up to you to recognize a pattern. So I'm just going to do my best to teach you tips and tricks to help you, once you do recognize the pattern, how to get an equation that represents that pattern. Okay, so directions here are for each pattern, write an equation where n represents the case number and a sub n is the total number of tiles. Then find out how many tiles would be in the 100th case. Okay, so this is our first case, this is our second case, and this is our third case. So first we're looking for a pattern. And it's not necessarily something that like the shape of it, but it's the number of tiles, what we're looking at, okay? So if you look at this one has 3, this one has 5, and this one has 7. So if you notice what's going on here is that it's increasing by 2. Now, if you're noticing more that it's increasing by 2, like lengthwise, that's absolutely fine. But the whole point is that it's increasing by 2. So now what we need to do is we need to write an equation that would represent that. So any equation that's increasing by 2, so going plus 2 plus 2 plus 2 plus 2 plus 2, that's a linear equation. And that means that the slope of the line is 2. So by knowing that there is a difference of 2, we know that this is linear and that the slope is 2. To write an equation of a line, we also need a point, right? That would work in this equation that we're about to write. So realize we actually have 3 points. We know that when we plug in 1 to our equation, we have to get 3 as an output. When we plug in 2, we have to get 5. And when we plug in 3, we have to get 7. So we can use any one of those 3 points. I'm just going to use 1, 3 because I feel like it. All right, so now we can use writing equation of a line, y minus y1 equals m times x minus x1 to get the equation of the line. Now, throughout this chapter, I'm going to teach you a faster way of doing this, but this is a way that will work because we already know how to do it. So y minus 3 equals 2 times x minus 1. Y minus 3 equals 2x minus 2. Add 3 to both sides. Y equals 2x plus 1. Now, if you look back at the directions, it says where n represents the case number. So instead of x, we're using n. And then the total number of tiles, instead of y, we should be using a sub n. So we have a sub n is equal to 2n plus 1. And that's how it's written in this unit. So I just wanted to introduce that to you. It also says find out how many are in the 100th case. So we're going to do a sub 100 is equal to, so we're going to plug in 100 for n. That's 2 times 100 plus 1. So in the 100th case, there are 201 tiles. So notice writing these rules is to help you continue a pattern and not have to actually physically continue the pattern. All right, here is the next one. Okay, so on this one, when I look at this and am recognizing a pattern, I actually see it in 2 separate pieces. So I see this section right here. Okay, and then I see this section right here. So this one, these 4, and these 7. Okay. So this is case 1, this is case 2, and this is case 3. And Nardi said that this was 1, 4, and 7. Okay, so there's a pattern going on there, right? But then we also have these ones that I colored yellow. So if you look, this is 9, 16, 25, or 3 squared, 4 squared, and 5 squared. So I need to get, let's talk about just the yellow part at first. So I know it's something squared, right? But I don't want to say it's n squared because 1 squared is not 9, right? I need it to be 3. So if I say n is 1 and I add 2 to that, that's going to give me 3. And then if I square it, right? So if I plug in 1 there, I'll get 9. If I plug in 2 there, I'll get the 16 blocks. When I plug in 3 there, I'll get those 25 blocks. So that's going to work for the yellow. Now I need to write an equation for the pink part, which if you look at that, that is increasing by 3. So that's plus 3 plus 3. So I know that that is linear. That has a slope of 3. And then I need a point. So this is case 1 and it gave me 1 block. This is case 2 and it gave me 4 blocks. This is case 3 and it gave me 7 blocks. So once again, I'm just going to use the first one, which is 1, 1. Y minus y1, which is 1, equals 3 times x minus 1. Clean that up. And you get y equals 3x minus 2, or a sub n equals 3n minus 2. So I have it separately. I have the yellow part and the pink part, but together is the whole pattern. So to write my equation, I'm going to take my yellow equation and add my pink equation, and then make that one big equation. So I'm going to expand, and this is a sub n equals. So I'm going to expand this. So I have a sub n equals n plus 2 quantity squared is n plus 2 times n plus 2. So I'm going to FOIL that, and I get n squared plus 4n plus 4, and then plus 3n minus 2, and then combine like terms. A sub n is equal to n squared plus 7n plus 2. And there's my equation. Okay, once again, if you thought of it a different way and you got the same answer, it works, right? Also, I would like to check mine. So this total is 10 blocks. This total is, what is that, 16 plus 4? That's 20 blocks. And this is 25 plus 7. This is 32 blocks. So that has to work when I plug in 1, 2, and 3. So when I plug in 1, I get 1 squared, which is 1, plus 7 plus 2, which is 10. Plugging in 2, I get 4 plus 14, which is 18, plus 2 is 20. That works. And plugging in 3, I get 9 plus 21 plus 2, which is 32, and it works. So it definitely works, right? And now I want to find how many are in the 100th case. So I'm going to do a sub 100. And once again, if I had to continue this, it would be a pain in the butt, right? So I'm going to do 100 squared plus 7 times 100 plus 2, which is a sub 100 is equal to, that's 10,000 plus 700, so 10,702. And I could use my calculator to check that, but I think my math is okay. All right, try some on your own.